You must have heard that nobody understands quantum mechanics, but the question is why? The answer is that quantum mechanics happen in an imaginary hyperspace, and its projection is realized in the classical world. This is why we have no understanding, because quantum features, when it interacts and it builds up, we have no idea how this happens. And we have no theory for this. We do not have any understanding how particular features of quantum mechanics is born in the hyperspace. But their results are seen, visible, measured in the classical world. So there is no measurement called quantum measurement, and we all that we have is a classical measurement that measures the uncommon, unnatural, non-explainable features which we assign to quantum mechanics. Well, I mean, over a decade back, when I was discussing this with Sir Roger Penrose, then one idea came to my mind. Why not? I mean, he himself told me that that there should be a theory of original theory uh, above quantum mechanics, from which quantum mechanics principles will be developed. And that's why, inspired by Roger Penrose's concept that we need to build a general mechanics, I proposed in 2016 fractal mechanics, and even in 2020 book I have included fractal mechanics. So why it is essential that we construct the hyperspace universe and its mechanics from an original mechanics. So what would be the original mechanics? So I came up with the idea that prime number, the way it generates the integers, as absolute non-physical, because you see that if you want to create quantum mechanics, then you cannot take space, you cannot take time, you cannot take shape of the pot. So space, time, morphogenesis, and all these kind of fundamental features which are integral to the classical world, you cannot use this kind of thing. So two things we are left with: one, prime numbers and integers, and two, geometric shapes. So that is the two ingredients you have to use. So we need to use a generic mechanics. So what would be that mechanics? Generic mechanics would come from the primal mechanics of the primes, that is used to, I mean, the density of primes, distribution of primes, the way it creates the integers. So that's what is the fundamental, the first chapter of my nanobrain book. And we assume assumptions are needed, otherwise science is not formed. So we assume that universe is a single point. That's the fundamentals of a self-operating mathematical universe, SOMU, that we have proposed. So in this point, so we have to normalize and make it undefined. So we add many arbitrary number of points to a single point to make it undefined and to do normalize. So we come up with a pattern of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and ordering. Ordering is important. Why? Because if you want to go for non-commutative features of the universe, then non-commutativeness could come from ordered factor of an integer. That means 3 into 2, 2 into 3 are not equal. So you have to count as 2, not as 1. If you count as 1, then it is commutative. But if you count as 2, then it is non-commutative. And non-commutative you address. And then there is abelian and non-abelian. Why abelian? Because transfer matrix. Transfer matrix is what? We say that a state is not a single valued function. A state is a matrix or a tensor. It has many different dimensions, some components at different dimensions. It's just like Avatar or Vishnu at many different universes, many different lokas, some part of it here, some part of it there. And then the story of Hanuman, that Hanuman lost all its power when he came here, and he had to remind it. So if you go to different lokas, you lose some properties and you gain some properties. So that the tensor matrix that represents a quantum state or a quantum interaction between two, and coexistence, superposition, entanglement, retroactiveness, all these fundamental four hallmarks of quantum mechanics actually is represented in the tensor with different values, that if this universe interacts with that universe, you get this property. So fractal mechanics comes from the mechanics of primes, and when we normalize it, then different kind of loops form, and from loops or knots you get different geometric shapes. So this is all about it. And when we compare different knots and different loops with respect to each other, the concept of time and concept of space arrives. So basically, if you have a big loop and a small loop, the ratio of it, how many times the small loop would rotate on the big loop, just like cycloids and that kind of mathematics. So how many times it rotates, it give you a perception of time, perception of space simultaneously. So there is no problem in creating spatiotemporal universe from pure mathematics, pure knots and other kind of derivations. So from primes you can do it. So that is the fractal mechanics. So fractal mechanics is a way by which primal mechanics links to classical mechanics via quantum mechanics. So primal mechanics, then fractal mechanics, then quantum mechanics, and then classical mechanics. So this fractal mechanics is basically a kind of morphogenesis that happens from the primal mechanics. So primal mechanics as is another above layer than fractal mechanics. So you could easily say that fractal mechanics is not the end. It cannot be the end, because fractal mechanics gives the holds the formulations of interactions of different universes and projection to the quantum world. And quantum world, you get incredible properties due to the beautiful features of fractal mechanics. While writing the 2020 book, I took different circles and loops and created all fundamental features that you see in quantum mechanics. The reason was that I wanted to deliver a clear message that fractal mechanics can generate all principles of quantum mechanics simply by locking and unlocking and integrating different kind of periodic functions. So 3D arrangement of clocks or polyatomic time crystals. When you do this arrangement, following the rules of primes by counting and then the restrictions of the geometric shapes, their arrangement, you automatically derive all fundamentals of quantum mechanics. So it is beautiful to see that the four different hallmarks: superposition, entanglement, retroactiveness, and quantum tunneling. All these features come from a single metric, that is density of primes, and how many ways you can arrange. So so when you make the loops and integrate them, you automatically find that there is always an incomplete loop in the phase prime metric that we created. If you go through our book, 2020 book, you will find that that there is always a loop that is never complete, never complete. You can never find a small part of phase prime metric which is complete in loops. There is something always outside. So that is what we call that Purusha is always get restricted when you confine it in a prakriti, in a small finite element. So that is one part of it. And then the second part of it is, that's why superposition is there. And entanglement is, you cannot find a single loop that is not interconnected with others. So that is the foundation of entanglement. And the past is because of the large different fractality of loops. So since there is a fractality of each and every prime number generates a fractality, that's why retroactiveness happens. So you go to the past and change it, because self-similar patterns are there at every scale because of the primes. And then quantum tunneling is that you will find self-similar features localized in a particular domain, and even if you go large number far, you will find localized over there. So at across different scales, for example, C2 symmetry, it could be anywhere, C2, C3, C5. a seed is created, and then you can find it far, far distance in some distant locations. So this kind of one symmetry to another, to another, to another, to another, you can delocalize, and you can transfer from one to another, to another, to another, wherever the symmetry suits you. So this is how all the four hallmarks of quantum mechanics is born from fractal mechanics, and fractal mechanics is born from the primal mechanics.